Good morning, everyone. My name is Sivakumar Rakshan, and I would like to welcome you to this ICT presentation. Today, our primary focus will be on the identification of internal components of Central Processing Unit or CPU. CPU on motherboard image. To start, here's an image of CPU installed on a motherboard. This component is the core of every modern computer. Abstract laptop image. A journey today will take us inside device like this to understand the fundamental technologies that power a digital world. Identification of internal components of CPU. In this first section, we will be identifying the internal components of a central processing unit. Abstract laptop image. As started, a CPU contains several internal components that work in harmony to execute instructions and process data. List of CPU components. The five key internal components will be discussed are the control unit, the arithmetic logic unit, registers, cache, and the clock. CPU on motherboard image. Let's begin with the first component on our list, the control unit. The control unit or CU is often called the brain of CPU. Its job is to fetch instructions to memory, decode them, and control the sequence of operation to execute those instructions. It directs the flow of data within the CPU and coordinates the activities of all other components. CPU CU image. This image visually represents the central unit's role as the command central of the CPU. CPU on motherboard image. Next, we'll look at the component that performs the calculation. Arithmetic logic unit. This is the arithmetic logic unit or ALU. This unit performs all arithmetic operations such as addition and subtraction as well as logical operations like AND, OR, and NOT. Essentially, the ALU is where the actual calculation and comparison happen. Abstract CPU image. The complex circuitry shown here symbolizes the millions of calculations the ALU can perform every second. CPU CU image. Let's move on to the next component, registers. Registers are small, high-speed storage location within the CPU. They are used to temporarily hold data and instructions that are actively being used by the ALU and control unit. Types of registers. There are several different types of registers, each with a specific job. The program counter keeps track of the memory address for the next instruction. The memory address register holds the memory address of the data being accessed. The memory data register holds the data that is being read from or written to memory. The current instruction register holds the instruction currently being executed. And finally, the accumulator is used to store the results of calculations. Motherboard close-up image. Now, we'll discuss another type of memory within the CPU that's crucial for performance. Abstract CPU image. This component is known as cache memory. Cache is an ultra small and faster type of memory than main memory or RAM, and it's used to store frequently accessed data and instruction. This allows the CPU to access this data much quicker than retrieving it from RAM, which help in improving performance. RAM image. This image shows RAM sticks and main memory, which works in conjunction with the much faster CPU cache. Motherboard close-up image. The final internet component we will discuss is the clock. The clock is the circuit that generates the series of electronic pulses at a regular interval, which is known as the clock speed. This clock signal is vital as it synchro- synchronizes all the components of the CPU and determines how many operations can be performed per second. Its speed is measured in hertz. Abstract CPU chip image. The clock speed or frequency of these pulses is a primary indicator of a CPU's performance. RAM image. Now that we've identified the components, let's summarize the overall function. Explanation of function of CPU. The section will provide an explanation of the function of a CPU. Abstract CPU chip image. As you've learned, the CPU acts as a brain of a computer. CPU functions. Its main functions are to execute instruction and perform calculation. It handles all the arithmetic logic and input output operations while also controlling and managing all other computer components. The CPU is responsible for interrupting and executing instruction from software, processing data to complete any given task. CPU block diagram image. This block diagram illustrates the CPU's central role, interacting with input, memory, and output units. Abstract CPU image. Moving on, let's discuss how all the different parts of a computer works together. Computer monitors image. This brings us to the explanation of how computer hardware components work together. How hardware components works together. Computer hardware components work together through a system of data transfer and processing. This is coordinated by the motherboard and facilitated by the CPU. The motherboard is the central hub connecting all components and providing power. The CPU processes instructions while RAM provides temporary storage for storage devices like HDDs or SSDs hold data long term, and the motherboard's chipset acts as a bridge for communication between the CPU and other components. Abstracts cloud and server image. Now, let's transition to the topic of data storage. Identification of different types of storage media. In this section, we will identify different types of storage media and explain the use of each with reference to its purpose. Types of storage media. The different types of storage media we will cover include magnetic, optical, solid state drives, and cloud storage. Magnetic storage like HDDs is used for large scale long term data storage. Optical storage, such as CDs and DVDs, is good for distributing media and achieving data. Solid state storage, like SSDs and flash drives, offers fast access, making it ideal for operating system and frequently used flash drive files. Abstract cloud and server image. Let's look at each of these in more detail, starting with magnetic storage. Magnetic storage devices. Magnetic storage devices uses magnetized particles to store and retrieve binary data. Common example are hard disk drives, magnetic tapes, and floppy disk. This storage method is non-volatile and relatively cost effective, through it generally has lower access speeds than other technologies. Hard disk drives. A hard disk drive is a data storage device used in laptops and desktops. It's a non volatile storage drive, meaning it can retain stored data even when it's not powered on. HDD image. This image shows the internal mechanics of a hard disk drive. Magnetic tapes. Magnetic tapes consists of thin magnetizable coating on a long, narrow stripe of plastic. It's used for recording and storing both analog and digital data. As a form of auxi- auxiliary storage, it's often used for long term data retention and backups. Cassette tape image. Here's a family example of magnetic tape technology. Floppy disks. A floppy disk or diskette is removable storage medium used to store data. These disks are made from plastic and metal and can hold up to 1.44 MB of data. Developed in 1971, it became widely used starting in the late 1970s. Floppy disk image. These floppy disks represent a significant step in the history of personal computing storage. Optical storage devices. Next, we optical storage devices which use light to read and write data. Common examples are CDs, DVDs, and Blu-ray discs. They store information in the form of tiny bits on the disk surface that are read by a laser. These devices offer a relatively cheap way to store and distribute large amounts of data like movies, music, and software. CD or DVD drive image. This shows an optical disc being inserted into a drive, a common action for installing software or watching media in the past. CDs. A CD or compact disc is an optical storage medium for digital data like music, video, and software. A standard CD-ROM can hold about 700 megabytes of data. CDs come in read-only, recordable, and rewritable formats. CD and drive image. This image shows an early CD-ROM drive, a technology that was revolutionary for its time. DVDs. The DVD or digital versatile disc is another type of optical storage medium. It can hold video, music, and computer files and offers a much larger storage capacity than CDs. DVDs are commonly used for storing and distributing movies and software. A standard single layer DVD can hold up to 4.7 GB of data. DVD player image. A standard DVD player which became a household staple for home entertainment. Blu-ray discs. Blu-ray discs are mainly used for high definition video and storing large amounts of data. They use blue violet laser which allows for a higher data density than DVDs and CDs. A single layer Blu-ray disk can hold 25 GB, a dual layer disk can store 50 GB, and newer BDXL formats can hold up to 125 GB. This is a significant increase from DVDs and CDs. Blu-ray disc image. The blue tint of these discs is characteristic of the laser technology that enables their high storage capacity. Solid state drives. Now we move to solid state drives or SSDs. An SSD is a storage device based on semiconductor that uses NAND flash memory to save data. This solid state technology is revolutionizing the storage industry with its high speed flash memory. SSD image. This image shows a modern 2 terabyte solid state drive. Cloud storage. Cloud storage is a service allowing users to store and access data over the internet via remote service instead of on a local device. It offers a convenient and scalable way to store files, access them from anywhere, and share them with others. Common examples including Google Drive, Microsoft OneDrive, iCloud, and Dropbox. Storage abstract image. The graphic represents the concept of cloud storage with data being accessible from a network of servers. Explanation of how data is represented in computer system. In this next section, we will explain how data is represented in computer system. Binary code image. In computers, all data is represented using binary code, which is made up of sequences of zeros and ones. This binary system allows computers to store and process all types of data, including numbers, text, image, audio, and video. Explanation of how encryption can be used to represent data. Now, let's see how encryption can be used to represent data for security purposes. Encryption lock image. Encryption is a method used to protect data from being stolen, changed, or compromised. It functions by scrambling data into a secret code that can only be unlocked with a unique digital key. How image and sounds are represented in computer system. Next, we will look at how specific types of media, namely images and sounds, are represented in computer system. How images are represented in computer system. First, let's focus on how images are represented. Pixel grid image and text. In computers, images are represented as a grid of tiny colored squares known as pixels. Each pixel's color is stored as a combination of numerical value of its red, green, and blue. components. These numerical values are then converted into binary code process. How sounds are represented in the computer system. Now let's discuss how sounds are represented digitally. Sound wave, image and text. In computers, sound is represented digitally through a process called analog to digital conversion or ADC. This involves sampling the continuous analog sound wave at regular intervals and converting the measured amplitude or loudness into a binary number. These binary values are then stored and processed by the computer. How compression can aid the storage of data, image, or sounds. This leads us to the topic of compression and how it can be help with storing data, image, or sounds. Data compression, abstract image. Compression is a key technique for managing file sizes and data transmission. Difference between compressed and uncompressed file. Let's compare compressed and uncompressed files. Compressed files offer smaller file size and allow for high-speed data transfer. However, some data can be potentially harmed in quality. Uncompressed, uncompressed files, in contrast, have larger file sizes and slower data transfer, but they contain all the original data in high quality. Description of the purpose of logic gates. We will now shift gears to discuss the fundamental building blocks of digital electronics, logic gates, circuit board, image, and text. Logic gates are the fundamental building blocks of digital circuits. They work by performing basic logic operations, no one or more input, signals to produce a single output signal. These are essential components in electronic devices for processing information in digital format. Main types of logic gates. There are three main or basic types of logic gates: the AND gate, the OR gate, and the NOT gate. AND gate. The AND gate provides an output of 1 only when both input 1 and input are 2 are 1. In all other cases, the output is 0. And gate symbol imaged. This is the standard electronic symbol for an AND gate or OR gate. The OR gate will provide an output of 1 if either input 1 or input 2 are 1. It only outputs are 0 if both inputs are 0. OR gate symbol image. This is the standard symbol of an OR gate. NOT gate. The NOT gate is the simplest one. It takes a single input and inverts it. And inputs of 1 becomes an output of 0, and input of 0 becomes an output of 1. NOT gate symbol image. This is the symbol of a NOT gate, often called an inverter. Description of the purpose of different types of computer network. Next, we will move on to computer networks, describing the purpose of different network types. Networks are the backbone of modern communication. connecting devices and people around the world. Computer networks are designed to facilitate resources sharing, communication, and data exchange between devices. They can be small, like local area networks in a building, or vast, like a wide areas network that covers continents. They also include wireless LANs and virtual private network for secure remote access. Local area network. A local area network or LAN is a computer network that connects devices within a limit area, such as home or office. LANs let users share resources and access the internet through a single connection. They typically use Ethernet or Wi-Fi and can support anywhere from a few devices to thousands. Metropolitan area network. A metropolitan area network or MAN is a network that connects users and resources within a geographic area like a city. It's larger than a LAN but smaller than a WAN. MANs often connect multiple LANs together to provide high speed data transmission. Wide area network. A wide area network is a network connecting multiple smaller networks like LANs over a large geographic area. It allows for communication and resource sharing between devices and users that are located far from each other, even across the cities or continents. Personal area network. A personal area network connects devices within an individual's immediate vicinity, such as a smartphone connected to a wireless headset. It's the smallest type of computer network. Virtual network, virtual private network. A virtual private network extends a private network across the public one, like the internet. It allows users to send and receive data as if their devices was directly connected to that private network. VPNs are used to enhance the security and privacy by encrypting internet traffic and masking the user's IP address. Description of the hardware, software, and transmission media used in computer networks. Now, let's examine the components that make up a computer network: the hardware, software, and transmission media. Hardware used in computer networks. Key hardware components used in computer networks include routers, switches, modems, and network interfaces cards. Routers. A router is a device that receives and sends data on a computer network. Router can be combine the functions of other network devices like modems and switches to improve internet access and manage network traffic. Switch. A network switch is equipment that lets two or more IT devices like computers communicates with each other. By connecting multiple devices, a network is created that allows resources like printers, servers, and internet access to be shared. Modems. A modem is device a device that allows computers and other devices to connect to the internet. It acts as a translator, converting digital signals from a computer into analog signals for transmission over phone or cable lines, and vice versa. This conversation, this conversion process is called modulation and demodulation, which is where the name modem comes from. Network interface cards. A network interface card is the hardware components that allows a computer to physically connect to a network. It serves as a bridge between a computer and the network, enabling all communication and data sharing. NICs are also known as network adapters or LAN adapters. Software used in computer networks. The software that powers computer networks can be grouped into several categories: network operating system, network management software, network security software, communication software, virtualization software, and network monitoring tools. Thank you. That concludes my presentation. Thank you very much for your time and attention. I'm now open to any questions you may have. Thank you.